This is the IoT for All Media Network. Hello, friends in IoT. Welcome to Let's Connect, the newest podcast in the IoT for All Media Network. I am Ken Briodagh, Editorial Director for IoT for All, and your host. If you enjoy this episode, please remember to like, subscribe, rate, review, and comment on all your favorite podcasting platforms. And to keep up with all the IoT insights you need, visit iotforall.com. Before we get into our episode, the IoT market will surpass $1 trillion in the next few years. Is your business ready to capitalize on this new and growing trend? Use Leverage's powerful IoT solutions development platform to efficiently create turnkey IoT products that you can white label and resell under your own brand. Help your customers increase operational efficiency, improve customer experience, or even unlock new revenue streams with IoT. To learn more, go to iotchangeseverything.com. That's iotchangeseverything.com. Now, let's connect. I am joined today by David Wilson, VP of Engineering at Intelinair. And we're going to talk a little bit about data management, IoT, and I'm particularly excited to talk about agriculture. David, welcome to the show.
Thanks for having me, Ken.
The pleasure's entirely mine. In case folks aren't familiar with you, David, or with Intelinair, can you give us a little bit of your background and sort of how Intelinair fits into the IoT space?
Sure. My name is David Wilson. I run all of the engineering here at Intelinair. We're taking data from many sources in agriculture and converting it to actionable intelligence for farmers, helping them manage their crops and increase their yields from many different sources. And we'll get into that.
And I think that at one time, farming would be the absolute last place anybody would expect IoT to be, and that's becoming less and less true as time goes by, because I think there's just it's an environment where we have so little control over the actual events that knowing more about how and when those events take place is functionally the most mission critical kind of data. Is that fair to say?
Yeah, exactly. I think agriculture is probably one of the last areas where technology really fits in. When you think of a traditional farmer, I think a lot of people have in their minds people with a horse and plow, and today's tractors, the Deere tractors in particular have all of these crazy systems on it, where the tractor drives itself across the field, tracks everywhere where it's been, and can tell us where every corn plant is planted, for example, within 4 inches on the planet. And that kind of data is at its raw form is really hard to consume because it's millions and millions of data points.
Sure. And I think that I'd like to start sort of at the highest level, because the difficulty, I think, in sort of agricultural data and farming data is, as you said, the many, many data points from many disparate sources about a lot of different things. And all of your decisions are made via trend identification and statistical analysis, and then hopefully leading to a certain amount of predictability, almost the way weather predictions happen. Close enough anyway. So, where are we sort of at right now with agriculture and IoT? I think everyone expects it to be soil moisture and rain and that kind of thing, but I know there's a lot more than that going on. So, can you give us a sort of state of the ag union in IoT?
I guess the things that we've discovered is certainly the information that comes off the tractor gives us a ton of information about what the farmer is doing on the field. Have they tilled? Are they applying products to the field, herbicide or insecticide, nutrients? Where are they putting the plants? And all of those things play into what's happening. We have topology data on the field, so we know given rainfall, where does the water run on the field? We have soil data that tells us where does the water accumulate? Which soils accumulate water? Which soils, sandy soils let the water run through? And using sensors there, you can really tell what's happening. We use remote sensing, so we're using aircraft or drones or satellites to measure what happened after the fact. And those sensors also play a big role in how we see what's happening. So you have, at the beginning, you have, here's what the farmer has done on the field, here's the natural environment, weather and soil, and then
Right.
you have the from that you can model what the expected outcome should be, and then you have satellites where you can measure what actually happened.
It's fascinating to me, and I sort of love this idea of the fact that someone that your average person pictures, as you said, on a horse and plow, is functionally an IT director and a systems integrator of their
Mm-hmm.
own enterprise, and sometimes that enterprise is more connected than some of the Fortune 500 companies out there, and doing really in-depth data analysis work. I find that
and
so fascinating.
and they're doing it for the same reasons the corporate people would. So the farmer's interested in predicting his yield. He measures it at the end, so he knows where things work well and can plan for the following year. But come June or July, he wants to know, what am I going to have at the end of the season, so that he can trade in the middle of July when prices are a little higher. You can get an extra 10 or 20% if you can trade early on what your yield's going to be. And the problem is, if you trade too much, then you have to go buy some at a cheaper rate and lose money. So they're constantly playing the market game as well. Yeah, it was one of the most amazing things for me, is to find out that farmers are also market traders, as a portion of the way they have to run their operation.
One thing that just occurs to me that's interesting is there's a lot of different kinds of farm globally, and certainly here in the U.S., you've got everything from the small sort of community farmer, I guess is fair to say, all the way up to big agribusiness and 100,000 big farms. And is this sort of data influx and data execution happening throughout that ecosystem? Is it happening more on the bigger side with the sort of large agribusiness companies? Where are you seeing this?
What we see in this area is that, if the larger farmers obviously are well invested in all of these technologies. If you have 10,000 or more acres, you're going to be more invested in these things. But the smaller farmers, even the 1 field or 10 field farmers, in the 100 to 1,000 acres, um, what they're doing, if they don't own the equipment, they're probably leasing the equipment or buying services from a retail company,
Mm-hmm.
what that has that equipment and is collecting that data on their behalf. And so many of the farmers across the entire stack, if you will, from small to the very largest, have access to a lot of this information.
That's really cool. That's super exciting, and probably makes agribusiness one of the more IoT integrated sort of vertical industries, because it seems like in agriculture it's become sort of a necessity to doing the business well and successfully.
But certainly the certain portions of the data is important for the management of the farm.
Mm-hmm.
And the next frontier is where Intelinair is sitting, which is converting all of this raw data into actionable intelligence that the farmers can actually use, right? And um, I would say the biggest challenge in this area is, yeah, okay, we have lots of data, but what do we do with it? How do we use it? How do we make it actionable? And while the equipment manufacturers have been very good at providing the ability to collect the data, the market has just now really starting to catch up with how do we use that to move things along.
Yeah, and so let's get our fingers dirty. As oh man, I'm never going to run out of this. Let's dig into that sort of analytics portion. What is what are the farmers looking for? What do they need to find? What are the relevant trends that they need to discover?
Again, in row crops, the lifetime of the crop is from when they plant. So in the Midwest, it's say April and May. They're going to plant to when they harvest in September. And then everything freezes up, and they do all their planning.
Right.
So they have this short time period where they can make some decisions to affect the final outcome. So between the time they plant and at a certain point the crop gets too high, they can't take equipment in the field.
Oh, okay.
And corn grows very tall. It gets somewhere around 3 feet or so.
I believe the official measure is high as an elephant's eye, if I remember.
Yeah, something like that. So there's a certain period where they can actually come in and make corrections. So we focus heavily on that early season part, emergence. What I plant, I put the seed in the ground. Which of them actually came out of the ground? Where are my problem spots? If I have holes where things didn't come up, I can go in and replant. So a lot of times, weather will come in, water will pool and kill the plant, or some other event will occur, and the plants don't come up. So we do replant, and then early season nutrient detection. So if the plants come up and they're yellowing instead of green, you can come in and reapply nitrogen. Maybe the nitrogen was washed away again by water or other actions. So that early season is the part where we can really have an impact on the operation of the farm.
And let's talk about how that analysis works. Is it algorithmic? Is it somewhat automated? Are we looking at more hands-on?
So my previous job was in IT management and managing IT data, where everything is time series based. You have samples that are happening all the time, and you're making decisions based on that. In farming data, we don't have lots of samples. Every 5 minutes we can't sample what's happening across the field. What we do have is various data that's all geospatially located. So I can cross-correlate data from many sources because everything refers to a place on the planet. And that allows us to build a model that says, given this place on the planet and all of these actions that occurred, you can build basically a stacked model of what's happening, of all the various data sources. So what we're doing is we're building basically a digital twin of what's happening in the real world. You have a digital model that says, given these inputs and what's happening in the real world, we now predict that the crop should be doing X, Y, or Z. And that's all done automatically. And then our turnkey service is to fly airplanes over the crop at multiple checkpoints, again, many times during the early season, and every week from May through June, and then every couple of weeks after that. During that critical period where they're every week seeing what's actually happening on the field and doing those checkpoints, and where there's a variation between where it should be and what the picture says is actually happening, we then direct the farmers to go and pay attention to those areas where they can make corrections.
How do you deliver the analysis to the farmer? What kind of UI, I guess, are we?
Since everything is geospatially run, basically you have, like your regular mapping application, think Google Maps or Apple Maps, and so we have a base map with the satellite picture, and then on top of that, we'll show you where your farms are, and then the analysis. So you have all the fields in your operation. You can see them. The analysis will color code everything according to what you're looking for. And then you can get into the details of all of the layers of data that we've collected. The platform's on both web and the iOS devices, iPhone, iPad.
As we're getting sort of near the end of our time, and before I give you the floor, as it were, to I want to sort of look at the meta analysis of all this data. We've got all these connected farms, all collecting data about and forecasting data about crops and yields and that kind of thing. That information to me seems extremely valuable, not just to the individual farmers, but to society as a whole, to government to plan for shortages if there are going to be any, and that kind of thing, and also to sort of ameliorate like food deserts and places where they don't grow a lot of food, and then food wastage on the other side where they grow food that they can't deliver in time. Um, is there must be work happening in sort of that meta direction. How far along is that going? Is that data, even if anonymized, shared somewhere that folks can access it? Is that
Yeah.
sort of piece of it part of the puzzle?
Well, yeah, Ken, that's obviously the direction that we need to go. One of our goals is to help manage the global food supply chain and really help with exactly the concerns you're bringing up. There are some challenges with data privacy. Farmers don't want to share. They'll share their yield information with us, but prevent us from sharing that out. Some of the analysis we can do, we can share. Certainly, the predictions that we do, and what we see on a broad scale, we can share out, and and definitely entities like USDA and the insurance companies are interested. The trading companies are interested in knowing, how much crops coming. Everybody's interested in that meta information. I think it's important for us to start to share that. Now, where are we at with that? I think the next steps, our company has focused very much on getting the algorithms right and understanding the what data we need to make the correct decisions. We're using airplanes today because it's kind of that middle ground. Drones don't scale well, and satellite, you got to deal with clouds and other things. But when I look to the future, satellite, we talked to a satellite provider. Their goal is to image the entire planet every 15 minutes. We talked with another satellite provider that wants to image on a tasking basis at 5 centimeter resolution. That's enough to find the golf ball on your front lawn. It's pretty amazing. And then we're also looking at satellite providers that are looking at more bands of data. What we can see is only a portion of the information that's available when you look down at the planet, and so there's plenty of movement to try and do this at a global scale, and our platform is moving right along with that. We're already bringing satellite data in, and you know and in the next year we'll have a global product that can work across many crop types.
So, as promised, we've reached the point where I give you the microphone, as it were. And if there's something that we haven't talked about yet that you feel like is important for the listeners to know about, or that developers of IoT technologies should be aware of if they want to join the industry or assist in the industry, or and basically anything, whatever you want to talk about. If you've got a manifesto that you'd like to read at this time.
Awesome. Hold on, let me get that out. My final thoughts would be, in I've talked a lot about the measurement side of it because that's the important aspect, but things like soil sensors, and knowing what data is available is important, but it's hard to deal with sensors on a field that you're going to tear up every 6 months, right? I got to go in and tear it up. So how do I get those sensors in a way that we can, you know, easily work around them, or and continue to make them relevant, or make them, easily replaceable? Certainly on tree crops and other things that last for years, it's easier to put in sensors, and there's plenty of opportunity there. I I think we live right now, and my final thought is this: we live in an amazing time. Uh, I think 5 years ago I was thinking, where are we going to go with Moore's law? You can only add so much more compute. The answer turns out to be we're going to go to space. SpaceX has opened the door to launching microsatellites that give us information across the planet. You see the SpaceX Wi-Fi coming up, the Starlink, and that's going to open a lot of doors. You see 5G on the horizon. That's going to open a lot more doors and allow us to really understand what's happening across the planet at a global scale. And that will lead to us being able to really manage the food chain as climate changes over the next 50 years.
Which I think is one of the major issues facing the globe. So I think I find that to be really, really exciting. David, thank you so much for being my guest and for telling us a little bit about what Intelinair has been working on.
Thank you, Ken. It's been a great time.
Thanks again to all of you listening out there. I hope you've enjoyed our discussion, and if you have, please make sure you like and subscribe so you don't miss out on any of our episodes. We post every week, and I hope you'll leave us a rating, review, and comment on your favorite podcasting platform. If you'd like to suggest a guest, please click on the link in the description, and we also have a great sister podcast on our network called the IoT for All podcast, so make sure you check that out.
Hey Ken, let me jump in real quick and introduce your audience to another awesome show on the IoT for All Media Network, the show that started it all, the IoT for All podcast, where I bring on experts from around the world to showcase successful digital transformation across industries. We talk about use cases and IoT solutions available in the market and provide an opportunity for those companies to share advice to help the world better understand and adopt IoT. So if you're out there listening and haven't checked it out, be sure to go check out the IoT for All podcast, available everywhere.
Thank you, Ryan. Now get back to your show. And thank you all for joining us on this episode of Let's Connect. I've been Ken Briodagh, Editorial Director of IoT for All, and your host. Our music is Sneaking on September by Otis McDonald. And this has been a production of the IoT for All Media Network. Take care of yourselves. You are listening to the IoT for All Media Network.